Now we can dive in Kubernetes concepts. And
So one question.
yes.
Can I start another application parallel to this one in the same?
Can we start another application in parallel to this one with Compose? Yes, you can start many applications, and each of them will be on its own private network. And another interesting thing is, let's say you have a bug in your Docker Coins app and you're like, I want to do some comparison with an older version. You can stage up both versions of the application side by side, each on its own network, on different ports, but on the same network. Each will have its private network, but if you want to connect to the outside, you will put one of them on port 8000 and the other one maybe 8080 or whatever, and they will be completely independent. So yes, you can do that. All right.
I always have to put them in separate folders, right?
And then yeah,
if not allocate the same port.
Yeah, if you, I'm going to stash the Compose questions on the side because the only reason why I was using Compose is to quickly start that app. But yeah, during the break I will stay here so that if you have questions, you are welcome to ask. I just want to try to stay on track. All right, that was 40 minutes of not talking about Kube. That's way too long. Let's dive into the important issues. So Kubernetes is a container management system. I spent this morning spinning up Kubernetes clusters. And so it runs and manages containerized applications on a cluster. Okay, what does that really mean? Like what can we do with Kubernetes? So instead of trying to explain like in technical words, oh, there is this and that, I wanted to explain what we can do with Kubernetes. Like a little bit like in Python, there is this duck typing concept. Like if it quacks like a duck, it's a duck. So then I don't know what this animal is, but it quacks. So it's kind of duck-like. So I'm going to explain what we can do with Kubernetes. For instance, I can say to Kubernetes, hey, I want you to start 5 containers using that image. And then I want you to put a load balancer in front because this is my internal API. So I want an internal load balancer for internal traffic. Now I want to start the web front end, so start 10 containers using that other image. Now I want a public-facing load balancer for this because this is the website for my shop. Now it's going to be Black Friday or Cyber Monday or Christmas or whatever, so there's going to be a huge traffic spike, so I want to have more nodes in my cluster and I'm going to scale things up, I don't know, like 50 containers. Oh, and also I fixed a bug, so I want to replace my current containers that are using version 1.3 with the new containers using 1.4. And also when I do that, I don't want to have a downtime, maintenance page, etc. I want you to replace the containers one by one, or maybe put everything, switch traffic, like do something fancy like that. I don't want maintenance and downtime. So that was kind of like the basic things that we will do today. There are a bunch of things that Kubernetes can also do, and we will not see these things today. I know I feel the sadness in your hearts, but we only have half a day. There is basic auto-scaling, which means like I want you to automatically add and remove containers when there is more traffic. You can do blue-green deployment, which is, okay, I want to have 2 copies of my app and I want to be able to kind of switch traffic between both. Or maybe I want to do A/B testing. I want to send half of my customers to this new version when the subscribe button is in red and on the top, and half of my customers to this version when the subscribe button is in green and on the side. And then I will see if I'm doing like better conversion rates, and I will keep the version that makes the higher conversion rate. And that is for front-end stuff, but also back-end stuff. Like, I wonder, we just rewrote that service, and so I wonder if it's faster. So I'm going to send half of the traffic to the old version, half of the traffic to the new version, and compare the metrics. You can have long-running services, but also batch jobs. Like every day at 4 a.m., I want you to run this big ETL pipeline. You can have priorities on jobs. Like, okay, every night I start this big ETL processing pipeline, but then if there is a traffic spike, we should like kick the ETL pipeline to make room for the web front ends. We can also run stateful services like databases, queues, etc. We can have fine-grained control so that, for instance, Bob can access these services and Jane can access these other services, etc. We can integrate third-party services and much more. Okay, so that's what Kubernetes can do for us, and that's just a subset. Now, what does the oh yeah, there was a question there.
Question: is this already out, or is this will be the upcoming version?
Oh, sorry, can you?
If this is already out, or it will be an upcoming version?
So the things I listed here in that like other things that Kube can do, some of them are already there, some of them are in beta, but everything is here in some extent. Like for instance, automating complex tasks, the operator pattern. It's something to, for instance, if you want to set up a SQL replication, but you want to kind of encapsulate that. So you want to kind of have a nice dashboard when there is just like add SQL server and clone SQL server or something like that. So the operator pattern lets you encapsulate that, and it's already available, but it's still very new. So it's the kind of stuff like if you just have a few SQL databases, you probably don't want to dive into that immediately. But if you're like, oh, I have thousands of databases for my customers, and I think I could save a lot of time with that, then that's probably something that you can look at. So what does the architecture look like? It's a little bit like this. No, that was not the real architecture. This is an architecture of Kube, but running with a separated CD cluster and with ISCSI storage and a few other components. Kube has the reputation of being complex, but it's not that complex. This is a more realistic diagram. So we have the master, and things can be a little bit complicated because often we think, okay, there is the master node and there are other nodes. In fact, the Kube master is a bunch of services, and traditionally they run on a node, and we say this is the master node, but they could run outside of the cluster. It's just a bunch of services, and again, traditionally, or rather, we try to run them in containers because it's more convenient, but they don't have to. If you wanted, you could just like have a machine somewhere with all those software components, like the things in that box on the left, running on that box. You could even like run that on your laptop directly, and that would be your Kube master. And then we have a, yes?
How good network do I need between the kubelets and master?
How, sorry, say
How
again?
good network do I need? Do I have some latency requirements and stuff like that between?
What are the requirements on the master? You mean?
Between the kubelet and the master. So can I run, I know, my master here and my kubelets in?
Oh, can I run different versions between the master and the nodes? You can definitely run the like different point releases, like 1.0 and 1.2. Now between different major releases, that's a good question. Excellent question.
That wasn't the question, but it's a good question.
That was not the question. I'm sorry.
What's the latency requirement between these two? So can I run latency?
Oh, latency requirements. Sorry. So it's fine if there is latency between the master and the nodes, but a lot of things are going to be slower, and at the point that a lot of mechanisms really it's a kind of feedback loop. So something happens, like a node goes down, the master has to realize that, and there are a number of things like, oh, this group of containers, like you wanted to have 5 of them, now we're down to 4, so I need to spin up one more, etc. All these loops are going to run more slowly, but it won't be critical. What is important though is that if you have a replicated master, the different masters should be close together, because they use etcd, etcd uses Raft, and Raft is extremely sensitive to latency.
What if the master itself goes down?
If the master goes down, then you can't access your cluster anymore. I mean, the rest of the cluster is fine, the applications are fine, everything is fine, but you can't make requests. If containers go down, like there won't be anything to restart them automatically. So yeah, you typically don't want the master to go down, at least not for long periods of time. Okay, so we have the master running like kind of the, yes?
Is there an HA for the master?
Is there a HA for the master? Yes. It's not trivial to set up, but yes. So we have the master and we have a bunch of nodes. The nodes are running like a normal Linux OS. They are running a container engine, typically Docker, but it could be something else. And then they are running a bunch of containers in pods. I will give a little bit more explanations about that in just a minute. And they also run a few system services, like typically kubelet and kubeproxy. Kubelet is the agent, if you will, that connects that node to the master. It's going to do the communication between the node and the master. And kubeproxy is something that will set up a bunch of IP table rules and kind of do some network plumbing so that the containers running on that node can reach other services. Credits for the diagrams. So in the master, so we have the API server, so that's the thing that we will talk to for everything. Then there are a few central services like the scheduler and controller manager. So those are the things that kind of run a loop that checks that everything is fine. Oops, we lost some containers, we need to restart them somewhere else, etc. And then we have etcd. etcd is a highly available key value store, and you can consider it as the database for Kubernetes. Like when you run something, very often you need to store data somewhere. So if you run a WordPress blog, it will typically be MySQL. When you run Kubernetes, the database is etcd. So when you want to have a highly available kube master, that's the thing that you have to worry about. Good news, etcd has been designed to be highly available, a little bit like Zookeeper, but the idea is that you have a bunch of nodes, and when one node goes down, you can connect to another node and everything is fine. It's not like with SQL replication when you need to do this failover and then you need to reprovision a new replica, etc. With etcd, it's been designed from the very beginning for scenarios where you blow up a node and it comes back, etc. All right. In the most complex deployments, typically you put etcd on another cluster on the side, and you have like a team dedicated to take care of that. The nodes, all right, so we, as I said, container engine, kubelet, kubeproxy. Sometimes in the documentation you will see something about minions. It's the former name for nodes. The tradition is that the master components are going to run on a node because that way they will be in containers just like everything else. But traditionally, your master node will not run other applications because the kube components require resources to run properly, so it's better to kind of isolate them from everything else. Of course, if you have a small dev environment, like your local machine, that's one node, so you're going to run everything on it. Do we need to run Docker on our kube cluster? So technically, no. By default, Kube is using Docker to run containers, and virtually everybody out there is using Docker to run containers with Kube. But if we wanted, we could also use Rocket, another container runtime for CoreOS, or we could leverage other runtimes using something called the CRI, the Container Runtime Interface. Oh, question in the back. Is Rocket stable now? It's a good question. So the best thing I can recommend you is to find people who are using Rocket and ask them what's their feedback and experience. Because I haven't talked to enough of them to be able to say either way. But yeah, the answer would be not yet. Cryo, I think you might have heard about it this week because I think it just hit 1.0. Cryo is a kind of super basic container runtime. The idea is, okay, we don't want to have Docker on our nodes because Docker is pretty heavy and does like 1 million things. So let's have like a minimal, like small container runtime, and that's the idea behind Cryo. There are other runtime as well, like crycontainerd, etc., etc. Now in practice, as I said, virtually everybody is using Docker as the runtime right now. This is going to change because there is this whole CRI initiative so that we can use other runtimes. Currently, like I've met people who decided, hey, we don't want to have Docker as the engine on the cluster, and they went with another option, and now they are rolling back because they ended up having tons of problems. I'm not saying, oh, you should stick to Docker. Well, of course, I work for Docker, so I should tell you that. But the truth is that today, like, that's the next slide, like, Today, we need Docker on the local machine and in like CI pipelines, etc., because it's super convenient. But and on production servers today, we are probably going to use the Docker engine. But tomorrow, probably not. Tomorrow, we are probably going to be using Cry Containerd or Cryo or something else, just to have something lighter on the nodes. Okay. Then more Kubernetes concepts. Kubernetes works with resources. As a programmer who learned about object-oriented programming, I like to think a little bit about resources like instances of something, and they have a type or a class. In the API, you will see that resources have a kind. So a few common resources are nodes, so that's the machines, okay. A pod, so a pod is a group of containers that run together. More of that in a couple of slides. Then we have a service. A service, I like to just say, okay, that's a level 4 load balancer. So it's a concept, it's like I have a service, so it's a kind of endpoint, like an entry point for connections, and it's going to send those connections to pods. Then we have namespaces to isolate things from each other. We have secrets, we have tons and tons and tons of resources. Like if I do kubectl get, it's going to list all the types of resources that exist, and you will see there are like pages and pages of resources. This is a nice diagram, and I would like to thank Luke Marsden for allowing me to use it. So we see that we have a node. Then in the node, we will have pods. And this is like the pods are the first confusing thing when you come with a Docker background, because with Docker, it's like, okay, I have a container, I run a container, end of the story. In Kube, we have pods, and pods can contain multiple containers. It could be just one container, it could be multiple containers, and they will run together because a pod is on one given machine, and they will share a bunch of resources. For instance, like the most important thing is that they will share the same IP address. So if you are in a container in a pod, if you look, for instance, at the IP address, you will see the IP address of the pod. If you use tools like netstat, you will see the sockets open or created like by other containers in the same pod. So that's a pretty important concept. And so when we will start containers, well, we won't be able to start containers. The only way to start a container is to start a pod. It's okay if the pod has only one container, but we will always be handling pods, never containers directly. Yes?
So a pod is basically a bunch of containers used to provide a service.
A pod is a bunch of containers that provide a service. It's like the different services that we put together are typically services that need to be collocated and wouldn't really be usable separately. Like for instance, if let's say you're using Apache with PHP in a separate process, then you could put that like Apache in a container of the pod, and PHP FCGI or the PHP server in another container in that pod. Or you could have typically app server and web server for static assets in the same pod. And if you read or hear about sidecar containers or sometimes sidekicks, it's the name we give to those extra containers that we add to a pod to provide extra features to the whole pod.